students. Today's topic is Ohm's law. Now what is this law about? Ohm's law gives us the relationship between the electric potential difference or the voltage across the ends of a conductor and the amount of current flowing through the conductor. Okay, for this you are supposed to perform an activity in your laboratories. In this activity the circuit is like this, that you see there are 1, 2, 3 and 4 cells connected in circuit in series with a key, ammeter, voltmeter and a load or the resistance XY. Okay, now what is done is, first we keep only one cell in the circuit, and it is your activity 12.3 in your NCERT book, and it is given there. The cell is having potential difference of 1.5 volts. So you know the potential difference or the voltage. Now what you do is, when you plug the key, then the current starts flowing and the ammeter gives you the reading of the current. So you make a table like this. You note down here number of cells 1, voltage 1.5 volts and current I 1 amperes. You can, theoretically we can assume any numerical value of any magnitude, but we have to do it practically, right? Then we increase the number of cells to 2. Voltage is now 3 volts and the current is I2. Then 3 cells, voltage is V3 4.5, current is I3. Then we increase the number of cells to 4, each cell of voltage 1.5, so the total voltage now is 6 volts and the current for this much applied voltage or electric potential difference is I4. Okay, now what you do is, you take the ratio of potential difference upon current, ratio of potential difference and current or voltage and current. So you get 1, 2, 3 and 4 readings, but what you find is that all the readings are same. It means that the ratio of potential difference to the current flowing through a circuit under similar physical conditions, temperature remaining constant, is constant. Okay, so this is the law given by Ohm, which we say Ohm's law. But my dear students, I would like to tell you one thing over here, that this is under ideal conditions. That is, in each case whatever you get the value of this ratio will come to be constant. But under day-to-day life, in your lab experiments, there may be a slight difference in the readings. So what we do is, we take the mean average of the readings. Okay, that is, you performed the experiment and you got 4 readings, then your resistance will be R1 plus R2 plus R3 plus R4 divided by 4. Okay, because under ideal conditions only, all the R1, R2, R3 and R4 will be exactly equal, not under laboratory conditions. Fine. So after this experiment, what do we conclude here is that the current flowing through a conductor is directly proportional to the electric potential difference or the voltage across its 2 ends or the 2 terminals, or voltage is proportional to current, or V upon I is equal to constant. Now when we say this, we know that if there is direct proportion, then the graph between those 2 physical quantities is a straight line graph inclined to time axis. Now I have drawn 2 graphs. This is graph A and this is graph B. So you have to be very particular in examination. If you are given this graph V and I, then slope of this graph will directly give you the resistance of the conductor. That is, slope is equal to V upon I is equal to R. Okay? But if the graph is that the current is plotted on y-axis and voltage is plotted on x-axis, then the slope, that is I upon V. Now you can see in that case slope was V upon I, which was equal to R, because we know V upon I is equal to R. But in this case the slope is I upon V, so it will be reciprocal of the resistance. So sometimes such questions are being asked in the examination, and students, they ought to do mistakes, so kindly take it carefully. Now let us try to do this, like this, that if you have this graph V and I, where V is voltage measured in volts and I is current measured in amperes, and there are two conductors or two circuits A and B, right? And this is the graph. Now let us assume that this is 20 volts, okay, and this is 10 volts, but the current you can see is same. Let us say 10 ampere. Okay. Now if we have to find the resistance of A, then RA will be equal to slope will be equal to V upon I, that is 20 upon 10, and the answer will be 2 ohms. Units of resistance are ohms in the honor of the scientist Ohm. Now, if you want to know the resistance of this B circuit or conductor, again it is slope. Now this will be 10 upon 10, because now this is the voltage and the current is same. So 10 volt upon 10 ampere, so this is 1 ohm. So sometimes you are given such questions that this is the VI graph, which conductor has high and which has low resistance, or which is a series or parallel circuit. So you see this angle. So greater the angle, greater the resistance. Lesser the angle, lesser the resistance. I think it is now clear to you. Okay. Now let us change the graph now. Okay. Now we say that this is the current in amperes, but this is the voltage in volts. Now you see slope of A will be I upon V, right? So if this is 20 ampere, okay, then if we say this is 20 ampere, then this is 10 ampere. Okay, so in case of A, you can see it is 20, let us say it is 5 volt, 20 upon 5, that is 4, but this 4 is not resistance, this is reciprocal of resistance, this is 1 by R. So 1 by R is equal to 4, therefore R is how much? R is 1 upon 4 ohms. Right? Now, slope of B. Now, this is also I upon B, and this is now 10 upon 5, that is 2. But again, 1 upon RB is equal to 2. Okay. Therefore, RB is equal to 1 by 2, that is 0.5, and this is 0.25 ohms. So you see, if the graph is reversed, that is current is here and potential difference is here, then is opposite. More the angle, less the resistance, less the angle, more the resistance. Okay, I think this is now clear to you. Okay, and the units of resistance are ohm. So R is equal to V upon I. If potential difference is 1 volt and the current flowing through the conductor is 1 ampere, then the resistance is said to be 1 ohm. So 1 ohm, and the symbol for ohm is this. Okay, thank you so much. I hope you understood the topic.